So good morning students. Today we will be continuing with our next topic of our chapter motion in a straight line. That means we are doing this chapter na motion in a straight line. So our next topic is we will be having a uniform motion. That means we will be describing what is uniform motion and what will be non-uniform motion. So first is, suppose a car is there. A car is the object. It has started from time t equals to 0. Now the car is moving. Suppose the car has reached 5 seconds. After 5 seconds it has reached to 5 meters. And after 10 seconds it has reached to 10 meters. And suppose after 15 seconds it has reached to 15 meters. So this is the interval of time. This is of 5 seconds. This is also interval of time 5 seconds. In same time interval it is covering the same distance 5 meters, 5 meters. So equal distance is being covered in equal interval of time. So this is a concept of uniform motion. So you can make a definition: equal distance covered in equal interval of time. So you make a guess by in real life examples which thing is doing the uniform motion. You know the earth is rotating around the sun and it is having uniform motion. It is covering equal distance in equal interval of time. Earth rotating around the sun. Earth rotating around the sun is an example of uniform motion. And here you can take the example of non-uniform motion. A car is there. Suppose in 5 seconds it has covered 5 meters, and in 10 seconds, suppose this is a time interval of 5 seconds, it has covered 15 meters. In this time interval 0 to 5 seconds it has covered 5 meters. But from this 5 second time interval it has covered 10 meters. So this is unequal distance in equal interval of time. So it is unequal distance in equal interval of time. That type of motion is known as non-uniform motion. So unequal distance covered in equal interval of time. In equal interval of time. In equal interval of time. So how you can take the example of this non-uniform motion? A car is there, it is traveling on the road, like your school van is there. That school van is doing the non-uniform motion. So you can take the example of a school van going on a road. That is an example of non-uniform motion. So this is our first topic. What is uniform motion and what is non-uniform motion? So we are moving on to the second concept, that are the displacement time graphs. So second concept, note down this heading: distance time graph. It's displacement time graph. So on one side of axis, suppose on y-axis you will take one quantity and on x-axis you will take one quantity. Displacement is a dependent quantity. You have to take the dependent quantity on the y-axis. So you will take the displacement, and displacement is in meter. And time is an independent quantity, and you have to take the time on x-axis. So it is in second. So you have to draw this displacement time graph for uniform motion. Suppose you have to draw it for uniform motion. Now you know what is a uniform motion. Suppose at 0, time is 0. Time is suppose 5 seconds. It has covered 5 meters. So what will be the point? The point will be here. Suppose in 10 seconds it has covered 10 meters. So point will be here. So this is point A, so this is point B. Join the origin with both these points A and B. You will get a straight line. So the displacement time graph for uniform motion is a straight line starting from the origin. So it is a straight line. Starting from origin. So take this value as, this is displacement, take this value as x1 variable, and this is also displacement, take this value as x2, and this is time t1 and this is time t2. Join this line and mark this point as C. So if it is 15 suppose, or if it is 10, so what will be the value of BC? 15 minus 10, 15 minus 10, that is 5. So BC value will be equals to x2 minus x1. And what will be the value of this AC? What will be the value of this AC? T2 minus T1. T2 minus T1. It will be the value of this AC. T2 minus T1. You have heard a quantity in 9th class, that is a slope. Graph, they are having the slope. What is this slope? Slope represents change in vertical quantity upon change in horizontal quantity. So vertical quantity is displacement and horizontal quantity is time. So what is the change in displacement? This is the change, x2 minus x1. So what is the change in horizontal quantity, change in time? T2 minus T1. So what is change? x2 minus x1. So what is the change? T2 minus T1. So this is the slope of a displacement time graph. You can write here as slope of displacement time graph. So what is there? This is displacement. x2 minus x1. What will be there? It will be a displacement. And t2 minus t1, it will give the time. Because if you minus 15 seconds from 10 seconds, you are going to get 5 seconds, and that is a time. And if you are going to minus 15 meter from 10 meter, you are going to get 5 meter, and that is a displacement. So remember this formula, velocity is equals to displacement upon time. So this is also displacement upon time, and this is also displacement upon time. We can write velocity in place of displacement time. Here you can write the velocity. So velocity is given by the slope of displacement time graph. So the slope of displacement time graph is given by the velocity. We have reached up to this conclusion. So in exam they can ask what information is given by the slope of this dt graph. This is the slope of dt graph. This AB. AB is the slope. This sharp portion from A to B, this is the slope. So they will ask what information is given by the slope of displacement time graph. So this has been done, velocity. And there is a question related to this topic. So we will be discussing that also. You can make a pause and write down these notes, okay? So second concept is, suppose you have given a displacement time graph. Suppose you have given a displacement time graph. Suppose they have given you a displacement time graph, and this is this is the slope of car A and this is the slope of car B. They will ask which car is moving faster. You have to tell him which car is moving faster. It's very much simple. Just take one time. Suppose it is T1. And note down at T1, B has covered a displacement of suppose 5 meters. And at the same time T1, note down the displacement covered by this A car. That is 15 meters. B car is covering 5 meters in time T1 and A car, it is covering 15 meters in time T1. So this is covering more distance, more displacement. So B is moving faster. Sorry, A is moving faster as compared to B. It is moving slower. So you have to take one time, and on the basis of that time you have to calculate the respective displacement covered by this B object and the respective displacement covered by this A object. So you will get your answer by seeing the slope of a line. If the slope is sharper, it will be like this. If the car is moving very faster, slope will be like this. If the car is moving slower, slope will be like this. If it's too slower, like this. So remember all these points. So we are moving on to the next concept, that are the velocity time graph for uniform motion. Velocity time graph. We have done the displacement time graph. Now we will be doing the velocity time graph. First we will do this velocity time graph for uniform motion. If uniform motion is there, that means equal distance. Object is covering equal distance in equal interval of time. So object is covering equal distance in equal interval of time. If the object is covering this equal distance, that means the object is moving with same speed. Speed is same. That means at every time speed will be same. So if speed is same, what will be the shape of this velocity time graph? So velocity is a dependent quantity, so we will take it along the y-axis. And what is the unit of velocity? Meter per second. You have to mention it in bracket. So you have to mention the time, and what is the unit of time? This is second. At time t1, suppose, at time t2, suppose, at time t3. Velocity suppose here 5. At t1 velocity suppose 5, like this. And at t2 velocity is same na, in uniform motion speed is same, so it will remain 5. At t time 3, at t3 velocity will be 5. So velocity is not changing. So we are obtaining the point this. This is point A, this is point B, this is point C. Join all these points. So this is the shape of a graph. So this is the shape of a graph, or VT graph for uniform motion. you are getting the VT graph for uniform motion. So this is a concept. This is very much simple. So VT graph for a uniform motion is a straight line parallel to the x-axis. You can write this. VT graph for uniform motion is a straight line parallel to x-axis. So this is parallel to x-axis. So we are moving on to the next concept of this topic only. Suppose you are having a velocity time graph. Here it is velocity and here it is time. Suppose your velocity time graph for uniform motion is like this, na? Take point 1 on this graph A and take B point on this graph. A is correspondence to some time and B is also corresponding to some time. So mark this point as C, mark this point as D. So you have taken C at T1 time and D at T2 time, like this. So this is the area covered under the VT graph by the object. Suppose you are observing this velocity time graph for time T1 to T2. So this is the area covered by the object covered by the VT graph. So area covered by VT graph. So what is the formula of this area? Area formula is length into breadth. So the formula of area is length into breadth. What is the length? Length is AB. And what is breadth? Breadth is BD. Okay. So what is this AB? AB value will be T2 minus T1. You know this. The value of AB, because this is T2 minus T1. What will be T2 minus T1? So AB is having this value. That means T2 minus T1. And what is this BD? Suppose it is having V velocity. The value of BD will be V. The value of BD will be V. So this is time and this is velocity. Write its word time into velocity, like this. Note down this thing. So write the left hand side here, area covered under VT graph. So you know the formula of velocity. What is the formula of velocity? Velocity formula is displacement upon time. Okay, displacement upon time. So if I multiply this velocity with the time, what I will get? I am going to get displacement. So velocity is being multiplied with time. Velocity is being multiplied with time. What will be the value? Displacement. Here it will come the displacement. So displacement is given by the area covered under VT graph. If you calculate the area under the VT graph, you are going to get the value of displacement covered by that object. If an object is moving on the road, you can draw the VT graph for that object. And if you cover the area under the VT graph, this is the area under VT graph. This area under VT graph gives the value of displacement. So this is very much important concept. Okay. So note down this concept. Area value is length into breadth. Length is on length portion. What is length? Is CD or AB. CD value is T2 minus T1. And what is BD? BD value is V. Time into velocity. Time into velocity is displacement. So area under VT graph gives us the displacement. So I am giving you an example concept. it is a numerical type question. You have, it's a VT graph. You have to means calculate the this is a VT graph. Suppose here velocity, here t. Upper portion velocity will be positive and lower portion velocity will be negative. Suppose it's 0, it's 5, or it's 10, and here it's minus 5, and here it's 10. Suppose. So 5 is the velocity, 10 is the velocity. So this is the area under the VT graph. Suppose like this. Like this. So its value is 4. 4 time is 4 here. So here time is 2. Here the time is 6. And here time is 10. Like this. Okay. So this value is equals to 10, and its value is also equals to 10, and its value is equals to 5. So what is the area covered under this VT graph? So this is the area. So it's having a value of 10. So it's having a value of 5. So this is the area that is covered under the VT. This area plus this area and plus this area. Find all the three areas. This area will also give the displacement. This area will also give the displacement. This area will also give the displacement. Add this displacement plus this displacement plus this displacement. You are going to get the total value of displacement. So this is a question. This is a VT graph, and this is first triangle, second triangle, third triangle. They have given the values of this triangle. You have to calculate the area under this VT graph, and you are going to get the value of displacement. So next concept is displacement time graph. We will be discussing this displacement time graph. Now we will discuss the displacement diagram, but for non-uniform motion. Non-uniform motion. Now you know the object is covering unequal distance, unequal distance in equal interval of time. So what will be the shape of this displacement time graph? And this is time. Okay. So what you are going to get? What you are going to get? You are going to get like the curve will be like this. Suppose this is the displacement time graph for non-uniform motion, because it's not a uniform motion. We are not going to get a straight curve. We are going to get a curved line. Suppose here A is there and here B is there. So according to A, displacement is x1. So according to B, displacement is suppose x2. According to A, time is suppose t1, and according to B, time is t2. Join these points like this. Now calculate the slope. Again you calculate the slope. Slope of displacement time graph for non-uniform motion. What you are going to get? Change in vertical quantity x2 minus x1. What is the change in now vertical quantity? x2 minus x1. What is the change in horizontal quantity? t2 minus t1. You can also write slope is equals to change in vertical quantity upon change in horizontal quantity. Vertical quantity is this BC, and the value of BC is x2 minus x1, and the change in horizontal quantity you can write value AC, and the value of AC is t2 minus t1, like this. So x2 minus x1, t2 minus t1. So you are going to get the slope. This is displacement, and this is time. Okay. You know velocity is equal to displacement upon time. You will say we are going to get the velocity, but this is a non-uniform motion. That means object is moving with different velocities at different times. Object is not moving with a single velocity at each and every time. Here our object is moving at different velocities. That means our object is moving with different velocities with the time. So we are not going to get the value of velocity error. We are going to get the velocity of average velocity. When the object is moving on the road with different velocities and you are going to calculate the velocity, you are not going to get the velocity, you are going to get the average velocity. So now in this case, this slope of displacement time graph for non-uniform motion gives the value of average velocity is given by slope of dt graph for non-uniform motion. So this is the value of average velocity. So it's giving us the value of average velocity. So value is like this now. The graph we have obtained like this, displacement time graph. It is like this. A is here, B is here. I've told you slope is like this, but here the curve is like this. So you have to make a proper slope. So join A and B with a straight line like this. So this is a slope. So what is this? This is T2 and this is T1. What is this? T2 minus T1. It's a change in time. It's a change in time. Suppose this change in time is 5 seconds. Okay, suppose this is 5 seconds. And if this change in time is decreasing, very decreasing, what will happen? B will start coming near to A. Suppose in this case, I'm going to give you example. This change in time has reduced. This is T1 and suppose this is T2. Now in this case, change in time, that means delta T, that means T2 minus T1 has reduced. It's in here size of T2 minus T1 is bigger and here size of T2 minus T1 is bigger. Now the B is started coming near to the point A. Suppose delta T tends to 0. That means it becomes approximately near to 0. What will happen? B and A point will collide over each other. That means this B point will come over the A point. It will come on the face of A point. So you will be having only one point now. Now calculate the slope at A. What will be the shape of the slope? For 2 points, if 2 points are there, this is the shape of slope. But for a single point, this is a curve now, this is a curve. For a single point, if you want to calculate the slope, it's a tangent line at A. Now the point has reduced to a single point on the curve, and you want to find the slope. Slope will be like this. Here the slope is giving you what? Slope is giving you average velocity. Now the tangent at point A, what information will be provided now? It will give you the instantaneous velocity. It will give you the instantaneous velocity. So when the you will say like that, when the delta T approaches to 0, A and B will collide over each other. A and B will collide over each other. B will come on the face of A. And if you want to get the slope of now distance time graph, displacement time graph, suppose you want to get the slope, you draw a tangent at A. A is on the curve. Here A is there. You draw a tangent. You know how to draw a tangent. In circle chapter you have read. That means slope of displacement time graph when delta t approaches to 0. So which thing is giving us the slope? Slope is given by the tangent at a point A, will be given by tangent at a point. So now you are having a single point, now you are having a single point. Okay, so this is a single point you are having some time, and at single point you are having some value of displacement. So you are going to get some information about the displacement and some information about the time. That means you are going to get the information about displacement and information about time. At a particular time you are going to get the value of displacement at a particular time. Now there is no particular time, there is a time interval. Here you are getting a particular time because delta t has approached to 0. Now you are getting at a particular time you are getting the information about the displacement. At a particular time you are getting the value of displacement. Now you will not get the velocity, you will get the instantaneous velocity. So you are going to get the value of instantaneous velocity. When delta t turns 0, the slope is given by tangent at point A, and that slope provide us the information about the instantaneous velocity. So this is final touch of this slope concept. Suppose this is change in displacement and this is change in time. So this is we are representing as B, C, D. Suppose this is change in displacement, this is change in time. You join these 2 points, you are going to get a line like this. This line is known as slope. This slope is representing a change in displacement and a change in time. So the value of slope is change in vertical quantity upon change in horizontal quantity. So in case of instantaneous concept, the curve is like this, no? A single point is there. You are drawing the tangent at point A like this. Suppose this is a point on a curve A, and tangent is like this, So this is a small change in displacement. This is a small change in time. So this is the slope. So this is more small change in displacement. So this is more small change in time, like this. That means when delta t turns to 0, this change in time will be very smaller and this change in displacement will be very smaller, and this will be slow, very smaller, and that slope will give us the value of instantaneous velocity. So you don't take by this is a tangent is a bigger line. No, at a point this slope That means slope is, what is this? Slope will be given by two quantities, change in vertical quantity change. Then only the slope can be created. And when the instantaneous concept is there, na, this displacement is having a single value. Displacement is having two values. When slope is bigger, displacement will have a single value, and time will also have a single value, like this, very small, like this. And the slope of the, we will say like this, here time and here displacement. So where we are going to get the slope? We are going to get the slope on tangent. So we will say slope of tangent at A. That means now we are going to get the slope on this tangent line. Tangent line is a very big line, but it is touching the curve at a single point only. So we will say slope of tangent at A. जो स्लोप होगी ना टेंजेंट एट ए की, वो ही देगी हमें क्या, विल गिव इंस्टेनियस वेलोसिटी. और वो कितनी होगी, बहुत थोड़ी होगी. जैसे ये स्लोप बहुत ज़्यादा है, पर वो वाली स्लोप बहुत ही स्मॉल होने वाली है, बहुत ही स्मॉल, टॉर्ट लाइक स्ट्रक्चर, ऐसा मान लो, इससे ज़्यादा नहीं. ये ना सोच लो भाई ये स्लोप है, ये नहीं है, ये तो एक टेंजेंट है. किस पॉइंट पे, ए पॉइंट पे जो टच करके गुजरी है, एक सिंगल पॉइंट पे जो टच करके गुजरी है. सो दिस विल बी स्लोप. क्या होती है, अगर कुछ बदलाव यहाँ हो, कुछ बदलाव यहाँ हो, तो इस बदलाव को जो रिप्रेजेंट कर रही है वो स्लोप है. पर हमारे केस में जो टाइम का बदलाव है बहुत थोड़ा है, और इसी तरह जो डिस्प्लेसमेंट बदलाव है वो भी बहुत थोड़ा है. तो स्लोप भी क्या रहने वाली है, बहुत थोड़ी रहने वाली है. तो वो बहुत थोड़ी स्लोप हमें क्या देगी, तब हमें वो वेलोसिटी नहीं देगी, तब हमें वो इंस्टेनियस वेलोसिटी देगी. So this topic we are going to end here only. Okay, we have read about the concept of uniform, non-uniform motion, displacement time graph for uniform motion, for non-uniform motion, velocity time graph for uniform motion. So this lecture we are ending here. I will give you some examples along with as homework to you. Tomorrow I am going to send you. So next topic will be acceleration. That will be in the next lecture. So thank you. Have a nice day.